All right. We're recording. Okay. So I was gonna look at inheritance and just give you another example of classes, but I also don't want you guys feeling like we're doing new material and leaving assignment 3 behind. So if there's something that's got you stuck where you don't know what to do for assignment 3, ask. So I think I had some people that were hitting assignments and then we're going, oh, I now I get them. So I want that kind of reaction from you guys. For this time, is it okay for the destructor is empty? You don't even need it if you don't have it, if you don't need a destructor. So that's a great question, by the way. Nice. Pointers in the program blows up, runs fine if it's empty. Okay, so we have there are two potentially different issues there. Let me hit that one first because I think it's important enough and it's for the assignment. So the question is, how are you actually making your nodes for your tree effectively? So I actually don't remember what my code looks like. So for my solution file, it depends on how I implemented it. If I just keep on adding nodes to the tree, but I don't know if I'm calling new and then adding the node, or if adding an actual node, or if I'm just adding data to the tree. The reason I have to sort of split that hair is when we look at inheritance for linked lists, we see this in another format where when I delete my linked list, I just clean up all the nodes inside, but no one knows I even have nodes. No one knows I even have nodes yet. So no one knows I'm making these node things in my linked lists. What I end up having instead is I have this structure, that magic box that holds stuff. So every time I insert something into my linked list, I'm not inserting a node into my linked list. I'm inserting some kind of data and it just gets magically stored. And what I want is when I delete my linked list, I need to clean up all of that stuff inside. So one of our cardinal rules is if my function calls new or my class calls new, it should be calling delete in a destructor. If I don't call new anywhere in my class, I normally don't need a destructor. The destructor is the cleanup. So if I do a big, like, there's a million one analogies. I'm just trying to find the best one in my head. Like I'm cooking supper now, let's say. So if I have to do this big fancy, I'm making Thanksgiving dinner, big fancy thing with a whole lot of pots and pans and stuff like that. I make a big mess. I got to clean up at the end, right? There's a whole lot of setup to get everything ready. There's a whole lot of pots, pans, stuff like that. And at the end, I need to clean that stuff up. I can't just, it's not the same as ordering takeout. I don't do any work and I just throw it all out, right? I do a lot of work to prepare. I then need to do a lot of cleanup. If I call new at all, I make a new array, I call new and make a new object, I need to call delete somewhere. I need to free up the memory. If I need to call delete somewhere, I do that in the destructor. And so what Maryse is talking about here is what I should be doing is if I called new in the constructor, I need to call new in the destructor. But a lot of people are making, let's say, an array, and maybe I did, I don't know. If I made an array of tree nodes independently, yeah, I don't call delete. I don't have a destructor at all, right? If I make an array of tree nodes, I don't need to call delete on the tree nodes in my tree. I can just call delete on the array itself. I may have to go down element by element down my array, deleting each of the elements in my array, and then delete the array. That is reasonable. But my thought is when I build this thing up, if I have to go element by element calling new, I also call delete same way, element by element, and then remove the entire structure holding it. If the object itself holds the information, then I don't need to do squat. Let's see if I can come up with a good other example of this. You made an array in main, and that's why. If you didn't call new in the, if you made an array in main and then called new in main to make each of those nodes in the array, then what you want to do is call delete on each of those nodes in the array, and then delete your array. I have this, so I have new point here. So to remind you, this is the old example from 2 weeks ago. Oh, so long ago, actually. Here we had this thing, source.c. Here's my source.cpp. I made new points, new point 1, 2, and 3. I'm going to make a new class, and I'm going to call it maybe vector. 2 points will make up a vector, or yeah. Any 2 points will make a vector, right? Or I could say a line segment or something like that, or line. 2 points will make a line. Sure. So I'm going to make a line class and see this in action. I'll do the one where I'm creating something. So let's see if we can do this. Shouldn't do the external file one. And class. And since I called it NEU, I'm going to add an EU line. So there's no base class. I'm just going to go. Okay. I will need the new point class simply because I'm going to be using that a bunch. Okay. And this is NEU point.h. That is what my header file is going to need. Why? Because no, Google. Google. The problems of doing a synchronized thing. All right, let's see if I can. Are you kidding me? Nope, it is not letting me do this. Okay, sync. I'll pause. So this .h. It's going to be okay. I have an access violation. Okay. So somebody has locked down this particular file and not letting me change it. Let me do this way. Close it. Yell at me? Yes, yell at me again. Okay. Sorry, this is just don't save. Something locked down my process. Hopefully it's fine. Okay. Include, and this will be NEU H. This is my new line.h. And then I'm going to have class NEU line. Right. Inside a new line, I'm going to have some private variables. I'm going to be, just for the sake of doing it, NEU line. First, in new point. BT1. Notice why I put the P underscore thing normally. It's because I forget if I have a pointer or if I have the original thing. So I'll often do this. You don't have to. This is me reminding myself, by the way, this is a pointer, just in case you forget. It's P underscore PT1. You don't have to do that. You can just call it PT1. That's fine. New point. 2 points will make up a line. Okay. I will need to make something to make a brand new line. So I need a constructor and destructor. And then new line. I want to have something here like question is, do I want to have 4 different points? Do I want to struct? What do I want to pass into this? Let's see what new point has. Oh, and X and Y. So that'll do. Well, let's do it that way. P1X, P1Y, and P2X, and P2Y. All right, I'm just going to, this is just for argument's sake, just to show something in action. Okay. I have a destructor, new line. The tilde just means this is the destructor. It gets called automatically. If I have a function, what looks like a function, but it doesn't return anything at the other end, there's nothing here, and it's called the name of the class, that's my constructor. That's how I know it's my constructor. If I have a tilde in the front, that's that squiggly, I know it's a destructor. Okay. I'm also going to get maybe length. Sure. Do I have something like that? Int. Let's make it an int. And get length. I have point get BT1. A couple of those. And void set PT1. P. And it's not X, it should be Y. Whoopsie. All right. I want sort of a minimum amount of stuff. Just I want to test out how this all works. Put it all in. Please say you're going to save. All right, save. Whew. Not one problem like I had last time. Okay. So because it does not know what the namespace I'm in, this is me filling out my obligations. I have a class. The functions have not been defined. These are the functions I'm going to have, but I still have an IOU. I owe this thing these functions. So this is me. That's what my CPP file is all about. It's me defining my functions. The things I said I promised I'd give, I have to, adhere to that promise. I have to give those functions. Now, technically, I'm not even sure you need it for this. I just out of force of habit, it doesn't hurt anything. But we can always remove that new line : : and see what happens if we wanted to. Just see. Okay. Okay. Let's figure out what we need to do here. My constructor, I'm going to make my constructor call new. Okay. So I forget the name of my variables. What was it called? PT1. Okay. Oh, I knew that. Okay. Good enough. Get rid of the this, but if I forget the name of my variables, I do that sort of thing. That's going to be equal to a new point. I have a copy constructor. I should have another constructor as well. I can even look at my other constructors. This, by the way, getting ahead of myself here, this is polymorphism. I have multiple versions of the same constructor. Depending on the parameters coming in, I call different things. P1X, P1Y. All right. I have P, P2, new point, P2, X, P2Y. I'm just creating 2 new points. That's it. This thing actually doesn't do much at all. Yeah, at least not yet. But since I called new, no one knows about this. These these objects within an object. No one knows about them. So the only way I can clean this up is if I delete them. All right. So what I'm going to do is this is for cleanup. Maybe I want to make sure that all my values are safe. Destructor, I may not need it, but when I'm cleaning everything up, if I have to freeze something, the only way, if I don't free it here, it doesn't get freed. I created this object. It's mine. It's my responsibility to give it back, and you don't give it back. If I move, I have a library book from the library, and I move to another country, they don't get their library book back unless I go have a way of cleaning up and just passing back the library book before I move. Right? When I'm done, I need to clean up. So I normally would want to do this. So if the one not equal to null, I'm not used to writing it this way. I'll do it my normal way in a second. Right now, delete the BT1. This is not an array; it's an object. So I just call delete. I don't call delete with a square parentheses. That's for an array. This is for an object. Okay, here's the way I would normally do it. If p bt2, that's it. If the pointer is null, it's equal to 0, which is also equivalent to false. So if it's anything other than null, then this expression is true. Yes, people actually do this all the time. This is standard. You probably have seen it in some of my other lectures, right? It's the exact same thing as this. It's if it's not equal to null, well, if it's anything but 0, it's not equal to null, and it's yeah. So if it's not equal to null, it's not 0, and therefore it's true. Okay. My hands are on the wrong keys on the keyboard, it turns out. ET2. If I don't do that, these things don't go back. And here's the thing I forgot for the first one. I should do it anyways right here. And in the first one, BT2 is equal to null. To prevent me from accidentally calling the destructor a second time. Just on the off chance, just get in the habit. It's like turning off the lights when you leave the room. You know, sometimes you might think you're going to go back into the room. Just turn off the lights anyways. Okay, I want to also figure out where null is defined. That'll do. Done. Null's just 0. I included standard IO would also include null. There's a whole lot of code that's going to include null. Null is just equal to 0. But when I'm done, I want to make sure that I want to make sure explicitly the pointer points to null, as in it's not pointing to anything. I will not be tempted to call delete a second time. That's the last thing I ever want to do. I can't call delete twice on the same object. Bad things happen, which is what actually the problem was. The delete my pointers in the program blows up, right? You call delete a second time on the same thing. So it was already deleted and you call delete on it again. That's where it blew up. So you can't do it twice. That's why your destructor can set it to null, but if you used an array, it wouldn't work that way. Okay, that is this. What else do I have here? So if p pt1 and p pt2, if both of those are not null, I want to figure out, I want the magnitude difference between p1 and p2, right? So I want p pt1 dot, not a dot, it's an arrow. Oh, because it's not, I didn't put this thing in here. Notice it doesn't even know what PT1 and PT2 are because I'm not in the class. Okay, now I'm in the class. I have a member variable called PT1. Great. I can get X. Let me see here. What I want is int diff X, just so I don't have to call this multiple times. Minus P PT2 get X. All right. I'm going to do the same thing for Y. In case you don't remember your linear algebra or Pythagorean theorem, that's all we're doing. We're going to take the difference in each of those things, square it, and take the square root of that. Add them together and take the square root of that. So I'll need math square root, actually. Okay, and math.h. All right. All right. So I'm going to use some math functions in here. So doubled distance is equal to diff x multiplied by diff x plus diff y multiplied by diff y. Yes, this is actually Pythagorean theorem, adding them together, and then distance is equal to distance uh, math dot square root. I think it's just square root, and I need a double in here, but that's fine. That's the distance. Square root of the distance is equal to distance. All right, and then I can return distance. Otherwise, return 0.0. Oh, it's 0. It's an integer. All right. Get BD1. Return BT1. I can, oh, if I'm going to set the variable, what do I need to do here? I can I can set, if I have the pointer already, let me look at what I'm doing here. I'm always making, not always actually, I might have a blank constructor here later, but let's check to see if the pointer actually exists. If it's existing, then I'm going to set the X and set the Y. Okay. If a 1 set X P X, okay, else BT1 new point. And then one last thing I'm going to do is let's just swap out all these things. Yeah, P X is fine. What's wrong with that? Capital X. 2, 2, 2, 2, X. Done. All right. And if I wanted to, let's do one more thing. Just, I know, sorry, I keep on saying one more thing, one more thing. Let's do, right. And what's yelling at me? Arithmetic overflow. We're going to pretend it's not going to give us an arithmetic overflow. It's giving us an error. I'd be checking into that normally. Okay. I want to check this, but I want to do one thing first. The out, meeting, fine. It should have been fine. So why is it not changing color? All right. I don't know why it didn't change color there, but oh, there it is. Okay. So let's make a new point. Um, and I'm going to pass in a bunch of numbers. 3, 5. -17, -3. And I need to include a new line. Should do it, hopefully. It has to be a pointer if I call new. But I change things around a little tiny bit. Access private member variable, new. Oh, there was something weird going on. For access private member variable, it wasn't private. Let's have a look at what we have here. Oh, it's protected by default. Public. All right. I'm going to run my code. It's not going to really do anything. It's just going to make an object. We're going to see when the destructor gets called. If the destructor gets called. I think it does get called, but we're lucky it gets called. Creating new line. Actually, it did not call the destructor. Oh, that's really depressing. Oof. See, that's I create a new line. I have a destructor that says deleting the new line. It never gets called. That's my responsibility to clean up that object I created and never gets cleaned up. I thought it did when you closed off the program completely. I think it closes off now, actually, right there. But I want to do it manually. I want to make sure it gets done. So here's source. I created the new line. I'm going to the new line. I want it, and I want to delete it. What I probably want to do is if p new line is not equal to null, boom. That's not the right word. P line. Sorry. Now I should see the destructor called. In fact, what's going to happen is I call the destructor. I then call the destructor after I've initially called the destructor. I call the destructor on the 2 points, and then I clean up the rest of it. I'm only done my destructor call at the end after I've deleted the 2 points as well. We're only going to see one of those, but if I put breakpoints in there, you would see it. All those you would see it. So, deleting new line. After calling deleting new line, I will call the destructor on the point. I'll call the destructor on the second point, and then I will delete finish off whatever else I was doing for destroying my new line object. Let's do one other version of this, just for argument's sake. Okay. Want to keep it in action? Okay. Oh my God, I can't touch my keyboard is wonky. Okay. Keep on missing the mark where I'm grabbing it. Line is equal to new, would be this. This is going to call that same function, but it's not dynamic memory. I'm just making, at the very beginning of my program, I'm making an object. I'm not calling new. It gets created without me calling new. It gets created automatically. Here's the reason I want to point that out. You're still going to see that destructor called without calling delete. So this is not relevant anymore, but you're still going to call the destructor. That's the only real difference that we have here. But sometimes I really want to call new because I want to call new when I want to call new. Otherwise, I need to know exactly how big my array is. I need to know exactly what the objects look like. I can't read information from a file and make my objects according to the information in the file. it's static. It always looks the same every single time. If it's going to change, like if like I call them I'm trying to get people in the class and I don't know how many people in the class, or if I'm making shapes for assignment 5, we're going to be doing a shape drawing program. And I don't know how many shapes someone's going to want to draw. I need dynamic memory. All right, let's um, deleting new line, creating new line. I call the constructor and the destructor, no matter what, if it's static, I don't get to control it when it gets created. It gets created at the top of the function. And when the function is done, I delete it automatically. No matter if I have to use it somewhere else, I get delete, it gets deleted right there. If I need this thing to stick around, I need to call new. And it's now my responsibility to clean it up. I have to call delete when I am done with it. Okay. And that's where all these weird, crazy things happen. Let's do brand new class. Let's do inheritance. I'm going to make a brand new class. It's going to be called Cube. Cube is not overly original or crazy, hopefully. I am just going to, hopefully, um, hopefully what my Cube class is going to do is NEU, NEW, right? To match the rectangle that we were dealing with. My rectangle class, if you want to look at it, let's save that. New rectangle. Here's my header file. I can get the area. The area is not going to change whether it's a rectangle or a cube. The volume might be new, right? But the area of rectangle, let's say it's always the front face of that cube. So whether you're halfway into the cube or the very front of the cube, the area is the same. It's the front plane of the cube. I can get the min, I can get the max for X and Y. Now I need a Z point, right? I need Z1, Z2, let's say. And let's see what other things I might need. Yeah, that'll do. I'll have Z1 and Z2 as well. Great. And and then I'm going to have a string get info as well. The same string get info, that's going to get us to polymorphism. That's what's really weird. I'm going to call the right function depending on what kind of object I am. They're both, maybe cube is not the right thing because cube will be a kind of rectangle, which is not, right? A cube is not a squares. Oh, squares are kind of rectangle. So let's do square instead. Square is a kind of rectangle. It'll be slightly different. We'll double check things. Okay. So let's go back over here. Let's do, I already had this in here, new square. So in this case, what I'm going to do, I'm going to find out I want something special in here. So there we go. I'm going to only ask for 2 points. Can I do that with 2 points? No. What I really want is I have 2 points. I want to make it a square. I'll take the minimum width or height between those two dimensions, no matter what. So I'll figure it out as I go. So instead of a rectangle, which can be a different width and different heights, right? The height and the width don't have to match. I'm going to make them match. It's going to be the smaller of whatever those two values are. So if you try and set the X value and it's too large, then it won't let you. We'll figure something out to make it work. Okay. The point of this is I might want, cube is also not the right thing, but we're going to, square is not the right thing, but we'll try it anyways. The idea is I want to use all the plumbing I have already for a rectangle, and just tweak it a bit. That's the idea. Same functions even. New class, new square. And here I go. I'm going to use the base class of new rectangle. All right. It's going to be a new rectangle with a little bit extra, right? A bat is a mammal that can fly. That's what's extra, right? A human is a mammal that's bipedal. Human is a mammal that uses tools. Human is like you can come up with a bunch of these things. It's a more it's a part of the main class is just more specific. So a square is a rectangle. It's just a bit more specific. The width and the height are the same. Okay, I'm going to look at what square gives me. The rectangle gives me, sorry. So instead of x, y width, oh, that's going to be much easier. I'm going to set them in x, set them in y, and forget it. I'm going to set the width, set the height. That's going to be so much easier if I do it this way. This is going to be nice. Okay. I have a min x, a min y, width and height. I can get the min x, I can get the max x, I can get all these things. I'm going to figure out figure out what I need to do for the square without even, I'm just going to store it in here. I don't even need new variables. The parent class is going to have the variables, and I'm just going to tweak things a little bit. All right, so I have some gets, I have some sets, I have, oh, and I only have getter methods. That's fine. Get area should work as well. All right. All right. So new square, I'm going to make whatever new classes that are going to override the old one. So, all right, still taking in 4 variables. We'll see this in action. I'm automatically, when I call new, I'm automatically going to call the parents version of the constructor, and then I'm going to do whatever special thing for my own. So a bat is a mammal, everything that a mammal has. Oh, also it flies, right? A little tack on at the end, or a little twist I need to do. I'm going to be able, these are not going to change at all, actually. Get area, nope, not going to change at all. We get rid of all of them. I'm going to make a new version of this one here, get info. All right, that's it. That's all I want. Don't need new variables. They're already there. They already exist. I'm not going to, they come for free. Produces milk to feed their young. Bats get it for free from being a mammal. Why? That's special about bats, right? Just a little, anything that's new, I add. Everything else, I leave it alone. So that's the grand rule of what I need to do. These 2 functions here, I don't even need the second function technically. All right. So new square. It's this kind of thing. It's, I happen to know, move my thing. All right. So by the way, it's class new square, which is a child class of new rect. That's what that says. It is a rectangle with a little bit extra. Here we go. All right. So instead of the other version of it, I'm going to fill this out in a second. This one here, I have a constructor. I can call I can actively choose which version of the constructor I'm going to call, the parent's constructor I'm going to call. So I can say something like new rect x1, y1, x2, y2. All right. If I did nothing at all, my rectangle and my squares are identical to each other. In fact, let's do this. CD string message. It's going to be, this is a web list. All right, that should do it, I think. Let's put a new line. I know, let's leave the new line off. Okay, and I'm going to return the message. I want to do a separate line. And you're probably wondering, why in the hell am I doing this? Well, because I can. Let's also go back to my source here. Let's find one of these squares. I'm just going to make it a rectangle. Get X. So here is a bunch of new points. Here's my old rectangle. I have a class called old rect. Oh yeah, that's the structure. Okay, here's new rect. Let's make a brand new rectangle. Same thing. Uh, rectangle 4. Let's make a rectangle 3. See, I'll just do the same thing as this one here. 3. It's not a new rect. It's a new square called R. Oh, let's call it S3. All right. Can't spell rectangle, but square. Get info and then the new end of line. Okay. I did nothing really here. There is no real difference between a square and a rectangle. It acts the same, looks the same, behaves the same. There is no real difference. The one thing you're going to see different is when I go to print it off, it's going to look different. That's the only difference that we're going to see. But I didn't change any of the other functions for setting methods. I didn't change the variables. I didn't change squat. It looks, behaves, does everything like a rectangle, but the output statement is different. Square S3. This is a square, honest. What it should say is the rectangle's numbers are 2, 2, 4, and 2. But instead, I have this other message that I didn't have before because I took the old one and said, no, forget that old message and just replaced it with a new message. I changed only the things that are unique to the new child class. That's it. Everything else stays the same. So don't repeat. Like every term I get people they'll have a class like the media class we're about to get to. That's for assignment homework. Yeah, assignment or do I call it homework? Assignment. Assignment 4, where you're going to have a media class, and then you might have make a movie media class, and that just looks like a media class. But there's a couple extra things. There's a director. There's no director in just general media. It might be a comic book. It might be music. Right? Media is anything that you entertains you, or you know what I mean. It's media. So a movie has a director. Comic book doesn't. Music doesn't necessarily. So maybe I have music media, and that has the artist or the album name. There's no album name in a movie. There's no album name in a TV show. So anything that's different, I add functions, I add variables if it's new, and everything else that's not changing stays the same. The file size is going to be exactly, I don't change that variable stays the same. It's in all of these different types of media because it's meant to be a media library that you're storing on your computer. So I'm only changing what I need to change. With a square, there is something I need to change, which is the width and the height have to be the same. The min x and min y, that stays, that's not going to change, but the width and the height have to be the same. So I need to figure out, can I actually set the x and y value? I may have to change some things around, but let's try and figure this out. I automatically call the rectangles version of to create things. I don't have, and I'm going to change. I know what's going to happen here, but what I want to do is I want to see what the minimum is of um, the width and the height. So I can get the width and should be able to. Oh, I get max air, max x, max y. All right, that's going to be get max x minus get max y. That's my width, right? Get this in here as well. All right, get the height as well. And this is a function. Now that I have that, I want to figure out what the smaller of the two is, and that's going to be ultimately what my max value is going to be. Okay. Hold on a second. Oh, okay. Can I do that? Actually, no, I know what I'm doing. Okay. Changing things around. Let's look at rectangle. Where is rectangle? Rectangle.h. I had min x, a min y, a width, and a height. Those are private variables. I may not want them to be private variables. Either I need to do a setter, I need a set method for setting the width, setting the height, setting the x, setting the y. Or maybe I only want the child class to be able to have access to this, to be able to change those variables. So instead of private, what I could do is this. This means I can change it, my children can change it, nobody else can change it. But now suddenly my children have access to this, provided that y is min x. Okay, there you go. So let's have a look at what new square looks like. All right. I'm going to call it n width for new width, new height. All right. Why? Because width is equal to, wait, I have access to the width now. My height, my width is going to be further down. I have access to the member variables for my parent class now because it's protected, not private anymore. Protected means the children get access to it. So if I do that, I now have the width. What I want to do is figure out if the height is less than the width, I want to change the width to be equal to the height. So if n height is less than n width, width is equal to n height. If n height is is greater than n width, height is equal to n width. So I have the width, I have the height. I'm trying to make them exactly equal to each other. So I figure out whichever one's the bigger one and just plop it down, chop it down to the smaller one. All right, let's do one other thing. I'm going to do this. This is Square Honest message plus equals, because you can do that, because haven't read why wouldn't you be able to do this? Actually, let's do append. And then I'm going to call new new rect. What if I did this? The new rect version of info. I can call the parents version of that particular function, which returns a string, which is I can append to the other string. I don't know what that's going to look like, so let's find out. What I expect, though, before I get going, come hell or high water, when I print off the dimensions of this square, my width and my height better be exactly the same because it says square. I'll have the same minimum x, minimum y point as I had before. but the width and the height will be exactly the same because it's a square. And I'm going to have some weird message about this is a square, honest, and then a bunch of stuff about, doing the output message for the rectangle. I could completely change the output message and not include what the rectangle originally said. That would be fine. Let's have a look. Square as 3. This is a square. Honest, the rectangle's number is -2 for 2, width of 2, height of 2. So -2 for, that's the minimum points. The width and the height are exactly the same. Great. It says the rectangle's number is this. I don't like that. Let's change it then. If I don't want that, I could go to my new CPP, find this thing here, and have something like this. Right? The two string, blah, 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 blah. I'll just use that and be done with it. Instead of using this thing here, a string plus the comma plus this plus that. I need to include. I'm not using the standard namespace. So SGD. And that standard library. Oh, and the other one. Ugh. Have some syntax there, right here. Let's see where my parentheses are ending there. Okay, we're good. No one hopes. All right. Once more. One more time. And please ask questions if you have. I know you have probably some burning questions in your head, and I've been yammering on like a drunken idiot here. So square S3. This is a square. Honest, -2, 4, width of 2, height of 2. Good enough. I don't have to call the rectangles function, a version of the function. I don't have to. I can. I don't have to. I could just remove it and put in a new version of it. But get width, get height, I didn't need to replace that. It worked. It ain't broke. Don't fix it. That's why we use inheritance, to be lazy. If you do it right, if you design things correctly and you think it through, you could be extraordinarily lazy. You figure it out once, and then you have like 20 different child classes that all use the same function, and you don't have to copy and paste code and stuff like that. Because when you copy and paste code and you made a mistake somewhere in the copy paste code, you got to replace it 20 times. Speaking from experience, that's why we have inheritance. One of the big benefits is that I don't have to keep on doing the same thing over and over again. I write it right once correctly, I get it for free in the child classes. Okay. Is that answering some? I didn't want to go too heavily into inheritance. I think we hit a fair big example in linked lists as well. That's a new video that was posted. Can I unpack anything else, especially for the assignment, let's say? Well, at least we still have people on the line. That's nice, but maybe you all fell asleep. Glad to hear it. Does anyone have any questions at all, or just hoping that just in case there was something new that we didn't see before? We can go. You can do all sorts of different examples with shapes, sizes, and pointers, and linked lists, and trees. Ah, the parent doesn't know squat. That's a great question. That's sort of the point. The parent. I hope you're not driving and getting away. You mean it's just snowing heavily, right? It's all good. Uh, I don't necessarily go hardcore on the videos on this one, although watch the video soon because that's what this week's lectures are. Um, the parent doesn't know about the child. That's the point. I can make this class. The parent is blissfully unaware that there's even a child at all. The child knows about the parent doesn't know about the child, which means when you're designing the parent, you can just make something. It's child's responsibility sort of to do things the right way. Sometimes like what I had to do with new square versus new line, sorry, new rect. In new rect, I wanted to change this around from being private to being protected simply because it would be a pain to try and do it another way. I probably should have made it protected at the very beginning anyways, but um, more like your great great ancestors. My great grandfather did not know me, did not know I would ever exist, knew nothing about me. He did not have an infinity gem or anything like that. I'm watching Doctor Strange right now when I'm going for jogs on the treadmill. Right? The time gem didn't know, you don't know about the future. You can know about the past, but you don't know about the future. Similarly, you know about your parents, but you don't know about your children because there could be great, 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 great grandchildren of your class. You'll actually see example if you did Java, you'll see weird examples like every single thing in Java extends from the class object. And so you'll have like just say 15 different classes. That's a child class of a child 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 all the way down. Everything extends from one like super class that everything extends from. C++, very similar things. You'll get child of a child of a child. Uh, and that's you can't expect the parent to know about the children. It's sort of the responsibility. And if you're making it a child class, which you expect to make later, if you make a child class, you adhere to the parent. You don't sort of expect the parent to adhere to you. Although I appreciate the point actually. It's a weird name. But yeah, that's the idea. Yep, the this pointer. The this pointer is, I thought it was the stupidest thing in the universe until I started having to use it and went, oh. So sometimes, just sometimes, you can't, you need to know where you are currently, or you need to be able to distinguish two things. So my variable is named min_x. Okay, I think I confused the snot out of people a couple weeks ago on this one, but let's try it. Let's confuse people again. Um, let's do things quickly. Use min_x. Oh yeah. Okay. Yeah, me being a jerk. Height, width, and I'm gonna break everything here. Oh God, this is scary. All right. Notice what I have here. If I go to newrect.h, I have variables named width and height. In new square, you might say, why did I do something as stupid as this? Why did I name, and some people swear by this, why did I name my thing width and height again? I have a variable named width here. It is not the same as the variable width right here. They are two variables with the exact same name, just like there are professors, instructors, two faculty members in the department, both named David, not Dave, David. How do you distinguish between the two of them, right? Are you doing research? Okay, then David Toohey. Is he teaching way too many classes? Then David Sprague, right? You have to distinguish them somehow. Did he make me cry? David Sprague, right? That's how you distinguish them. So in this case, we need some way of distinguishing which version. By default, honest to God, by default, the local variables always take precedent. If I say width here, it means it's width here, not the variable in the member, not the member variable. this random blip of a variable that I'm going to give back to the system 2 minutes later. If I want the member variable, I need some way of saying, no, 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 the member variable. That's where the this comes in. In this object, that member variable. That's what this is often for. It is a pointer to myself, this guy, right? It is a pointer to myself to say, I want this particular thing. It has a couple uses. One of them is sometimes I need to be able to point to myself for random reasons, for various reasons. The other big point of this, though, is this. The other big point is just pure laziness on my part. So sometimes you need to point to yourself. Sometimes you need to disambiguate the min from this other min, or the width from this other width, right? I have multiple variables. I want to, unless I force people to have different variable names each and every time. If I call this thing width, how do you know that there's another variable called width and that you're not allowed to call this variable, the member variable width? It leads to other problems. So instead, we say, if you want to have a member variable, you use the word this, the variable for this object. The other thing is just purely laziness. I get auto completion when I write the word this. I get, here are all the functions for this class. Here are all the member variables for this class when I type the word this. And I have a horrible memory. I forget the name of my variables. I forget the name of my functions and all this kind of stuff. And when I forget, I type this arrow, boom, I get an autocomplete. I can find it because there's no way I'm remembering it, especially like if you're looking at the parent of the parent of the parent of the parent. Like if I don't want to have to go to all these other classes, typing this, I get an autocomplete and I can figure out what functions I have available to me. That's just purely laziness on my part. But the this pointer allows me to point to myself and say the member variable for this particular class. It helps resolve ambiguity. And quite frankly, it seems weird, but enough people use the same variable name in the member, like as an input parameter as the member variable. There's actual communities of programmers that's what they swear by. The variable coming in should be the exact same thing as the member. So when I call set, um, I don't have a set method here. If I have a set method, the variable, the parameter coming in should be the exact same name as the member variable. So I know what member variable I'm changing. And now I have to use a this pointer. So if you don't like this, you can try and avoid it. You should be aware of its existence. Okay. Other predicaments, points of confusion, concerns. Does making a class make sense in terms of what it's doing? Because that was a point of concern is here I am making a class. I say, here's the name of my class. Here are all my functions I owe you. Here are all the member variables that I owe you that are wrapped up in every single object that I make. Every class, when I make a new instance of the class, it's an object. And every time I make a new instance of the class, I make all new variables that are wrapped up in this. I have a whole bunch of functions that are wrapped up in this thing. The object holds all of this stuff. The CPP file, the separate CPP file is because I'm lazy. And if I had everything just shoved into a .h file, every time I compiled my code, I'd have to recompile everything because I don't know what the dependencies are. With a CPP file as a separate thing, I only recompile that one object, not everything else. So literally it used to be if you had to make even the slightest typo change, like even the slightest change to a header file, you'd be like, oh, because you then compile your code and then go off for a coffee. If you're talking about a large code base, like a lot of projects are, it's a 10-minute wait compiling your code. Like the Unity engine, 10-minute wait compiling when you compile your code and you have to compile all your header files. know where to put the functions and the constructors and destructors and everything else that needs to be used, like which things go in which file in the project. All your header files, that's where all the declarations are. So that's a great question. Here are my declarations for new Square. It is the name of my class. Here is my constructor. If I have a destructor, the destructor's declaration is going to be there. Any of my functions, the functions go there. Everything I want about that object for that object, one object, right? Think of it as self-contained unit. Everything I need about that object is in the header file and the CPP file. Okay. Um, which go in which file? I'm trying to figure out what you're meaning by what goes into which file. It's not arbitrary. Like for new square, I'm making a square object that does stuff with squares. So when I want to get the area of a square, get area would be the name of the function. It's you. If you're figuring out the area of a square, it goes in the square class. Uh, any variables I have involving squares in the square class. Everything that I need for a square in the square class. Everything I need with strings. You've already encountered this. I don't call like str or some stupid thing like that. I have a string and I say, hey, string, how long are you? And the string goes, I am this many characters long. And you go, thank you. Everything involving a string goes in the string class. Everything involving a square goes in the square class. You organize it based off of how you would naturally think about this. You control your own fate. Your computer, like your the rectangle controls its own fate. The mouse cursor controls its own fate. The button that I have, let's say, take a button like this one here. It controls its own fate. So when I move my mouse over top of it, the button decides if the mouse is over top of it. The button decides how to draw itself. The button decides whether it's a hover state, a click down state, whether you've clicked the button or not. So all the functions involving buttons or that kind of button is in that class. I don't know who the heck is calling me, but thank you, spam caller. Yes, I find it very distracting having a phone call. Anyways, so I'm just trying to figure out what's stopping you from coding then in that case. It's a perfectly fine question, and I understand what you're saying. I just need a bit more specifics to make sure I'm not lecturing on something that's not actually a problem. So every class, pretty much every class should have a constructor. If the constructor called new at all makes anything new, dynamic memory, make a new array, makes a new object, anything like that, like we did with our new line, I called new a bunch of times, twice to be exact, then I needed destructor, something to clean up after myself, right? If you make a mess, you got to clean it up. So I made a mess, I asked for memory, I made a mess, I got to clean that thing up. So I need destructor. And then every function involving whatever that object is, I need the methods for those objects. And that just takes practice and time. In the case of, so everything involving nodes in our tree, right? If I need to get the child class or the child of my node, get child one, get child two. If I need to set the child, set child one, set child two. If I need to find, there are ways I can say, get the path from this thing to this thing. And that's a lot more complicated. It involves getting the path from my child. And then if there's a path from my child, then adding myself to it. And it gets kind of weird and wonky in your head. But it would go in the node class. The tree itself, if I need to have the depth of the tree, if I need to figure out how many nodes are in the tree itself knows how many, has a function like get number of nodes. The node itself says get how many nodes underneath it, let's say. And it's that combination. You're thinking, if from the tree's perspective, how would I do this? Okay, now that I'm in a node, from the node's perspective, how do I do the rest of this? You instead of thinking of it as just a series of steps, it is, if I'm in this object, if I'm in this thing, what would I do? Much like if I'm a robot in a maze, and this is how we actually normally teach programming, or at least how I learned. If you're a robot in a maze, how do you traverse the maze? It's from the perspective of the robot in the maze, not something else. It's not a series of steps. It's I am this robot in the maze. What are the steps I need to take? Those are the functions you're going to need. I'm still not sure if I answered your question. The function is declared in the header, so I know it exists and other people can use it. Notice, let me see a good example. You get an example. New square.h. It needs to know that there's such a thing as a new rectangle. Let's go to new square.cpp. There's no include new square.h, a new rectangle.h. All it's including is the header file for a square. The new square.h includes other header files. The header files are just the bare minimum. They're the scaffolding. They're the bare minimum things to know what related to what. You know, what courses are you taking? What course are you going to take next term? I'm going to take this course, these 5 courses. That doesn't mean you took those 5 courses. There's a lot of work to be done when you're taking those courses, but the brief outline of what your schedule looks like, it's not the same as taking the courses. It's just the outline. And you want that light and fluffy like scaffolding to figure out how things interrelate. So new square knows about everything that's in new rectangle, all the functions in new rectangle. It doesn't know how they're implemented. It just knows there's these functions in new rectangle. So when I include new rectangle.h and I say this is a child class, it says, I know there are going, it doesn't have the CPP, it just has this. It knows that there's a function called getArea, there's a function called minx, there's a function called minY, there's a function called maxx, maxy, getmaxy, getinfo. It knows these functions exist. It doesn't know how they're implemented. You're not supposed to know. It knows there are 4 variables because they're protected. It knows there are 4 variables in that class. Doesn't know how they're set up or anything like that. It is, I know this is sort of the blueprint. This is how this thing looks. This is what functions are available to me. This is what variables are available to me. When you're making this, I now owe you a function called getArea. I'll put that in my CPP file. I owe you a function called getMinX. I got to put that in my CPP file. Everywhere I had one of these functions declared, I need to define, like our prototypes when we were doing C, right? We had these little prototype stubbies at the top of our file. And then I owed you the actual function definitions at the bottom. This is my stubby. This is my prototype. I owe you a function called getArea. Other people are relying on this function being called getArea. And then I define getArea over here. Here's getArea. In the class new rectangle, I'm defining the function getArea, which I owed you. Here it is. Boom. This is getArea. Um, yeah, it should remind you of Java classes. Java classes almost exactly mimic this. The difference is Java said, we're not going to make you make a header file as well. It's just they're almost equivalent. All these languages you can switch from one to the other. There's no sacred thing or sacred one right way of doing things. They all have pros and cons. Java does a lot of things really well, but people hate the garbage collector, which is you don't need to call delete. It'll delete for you when it feels like it. When you stop using it, it'll delete it sometime, which means if you're making a video game, you can suddenly get this huge slowdown in your processing speed at the most inopportune time, and there's nothing you can do about it. That's why people like C++, because you're in complete control of every last little thing. It's um, like you building your own airplane, though. It's and about as dangerous as well. It's very similar to Java classes. The only difference is think of the header file as the Java doc, right? When I make a Java doc, right, I have there's special kind of ways of writing notating Java, where it says this is what the little, actually it's the comment at the top of a function. I'll get the name of the function, the comment at the top of the function. Those get pulled out and saved somewhere else. That's the Java doc that you can make. That's all a header file is effectively. It's a Java doc. It's how do I use this thing? So I can pass you off new rec.h. You do not need to see new rec.cpp. You shouldn't see new rec.cpp, but I can pass you the header file. You can look at the header file, know exactly how it works or what is available to me. I can look at it and say, oh, there's a function called getArea. There's a function called getMinX. There's a function called getMinY. That's actually what's happening here. I'm including the header file. The CPP file has already been compiled into executable code. I can't look at that file. I can use it, but I can't look at the code inside of it. But I can look at this code. I can see what functions are available. The CPP file sort of fulfills the obligation. I said I'd make a function called getMaxX. Here's my function called getMaxX. That's why we separate them out. Because if I put all the code in the header file, everyone can just take my code and run with it. I pass off some of my header file and they go, oh, thank you for that algorithm. And then they steal my code and make Windows. Oh, sorry, that's just a different example. That's what we're looking at here. The header file is just a safety, it's sort of a safety precaution. It is, here's the outline, the actual, or the table of contents, the actual stuff, all the actual code, that all the fancy pants algorithms you're going to write, they're all in the CPP file. But the header file lets other code to know about what functions are available. That makes sense? So header files, IOUs, and then the actually following through and actually delivering on the code, that's the CPP file. Array 3 is child, is connected, and is leaf function supposed to be in the tree node class. How would you, what's a tree? Is leaf on a tree? Tree is not a leaf. The nodes have a leaf, are a leaf or not. But is leaf is only for nodes. It's the leaf of a tree, the end point of a tree that has no children, essentially. Has one child, it's not a leaf. Are two nodes connected to each other? I'm in a node and I say, are you connected to this other node? And you say yes or no. Only makes sense for a node, not for a tree. The tree might have, what's the depth of the tree? How big is the tree? How many nodes I have? That might make sense. Does it include this item? That might make sense for a tree. Our tree is stupidly simple compared to actual trees. Actual trees are way more complicated than this. But for our case, is it a child? Is something a child of me? Doesn't make sense for a tree. I don't have a child of this tree. It's, is this node a child node of my tree? And yes, I realize that we're talking about child classes and child nodes. They are actually different. Notice that what we actually have is objects are actually a hierarchy. They're a tree. Parent class, child classes, grandchild classes below that. It's a tree. We love trees. Everything's a tree. We throw trees in everything. And this is just another example. My trees, when I'm making a tree class, I call child of a node. I have leaf nodes. I could say a leaf class if I wanted to, a class that does not have any child classes, right? Your inheritance gives you a tree, a hierarchical inheritance tree for an object. It forms that same kind of structure, that kind of branching out structure. That's why they're both called children. As in main, you will make a tree. You will add tree nodes to the tree. You'll test to see if the tree works as you expected. But a tree is like we had a struct, right? We had a struct called a tree 2400 struct. We have a tree object instead of a struct. Everything we did in A1, you do the same thing for this one. Instead of a tree 2400 struct, I have a tree 2400 class. I make an instance of it. I make an object of type tree 2400, much like I made a struct of tree 2400. Same thing, right? So what I had as a struct before, now it's a class. Okay, and that struct, that struct had tree nodes, other structs inside of it. This tree object has tree node objects inside of it. It is verbatim exactly the same as A1. So a tree to a tree, one's a struct, one's an object, and they each have what they actually have is just the root, the first node of the tree. That's all they need to point to. And that node points to other nodes, which point to other nodes, which point to other nodes. The same code as we had for A1, we had for A3. That makes sense, hopefully. So yeah, if you get confused, look at the A1 solution. It's there. It's just, I'm intentionally saying it's just a transformation from using structs to using objects, but the approach is effectively the same. Much like A2A to A2B, effectively the same thing. We went from C strings to string objects just to compare as you dare between the two. They're not identical, but there's so much in common that, it's designed to remind you of, oh, this worked this way last time, works the same way now.
Hi, can you hear me?
Maryse, you want to say something?
Yes.
I don't know if you're unmuted suddenly.
Yep. Can can you hear me?
Oh, I'm muted. I have a headphone thing. All right. Recording. Okay, let's see. Can I try again?
Can you hear me? Hello?
I'm not hearing squat. Hold on. How's this?
Can you hear me?
Yep, can hear you now.
Okay, good. Like it's probably just a minor thing, but I was just wondering because the way the get text info function is in the tree node CPP file, and then it gets called with the pointer in the arrow to get text info. I just didn't know if you wanted us to do the same for the other three, the is child is connected.
Those are only tree node in particular. It's more the get text info. If I want to say that the text info for the entire tree, what do? I say, hey tree, tell me all your text info. And the tree then asks the first node, which then asks the child nodes, which then asks this. The tree nodes then ask themselves to print out information about themselves. So how do I want to say this? We'll do this with the media library. If we have a collection of media, like movies, let's say, if I want the entire collection of all the movies I have, I say, hey, media library, tell me what you have, like what kind of media you have. And the media library then goes to each of those media objects and says, hey, say what you are, say who you are, right? If I said, give me the class roster, what could I do? I could just say, hey, everybody sign this, or, take attendance. I say, hey, everybody, fill on this sheet, this attendance sheet, and each of you would fill in the attendance.
Right.
Right. So it's the idea that the tree can then call the tree nodes functions. They both are called print info. All I'm doing, the tree is just calling the first node's print info, which then calls the next node's print info, and the next node's print info.
Okay.
If you notice that there's this sort of cascading thing, it's always the tree calls the node and then the node does everything. The tree hardly does anything. It just wraps up stuff.
Mm-hmm.
We actually see that with the linked list class, by the way, if you want to see another example of it. The linked list class says, okay, go to my first node, and have the first node do everything. It doesn't do anything else. The node then calls the next node, which calls the next node, which calls the next node, which calls the next node. I don't have to do squat. I just, let the nodes do all the work. They're like Oompa Loompas for my code.
Right. That's for the bonus question, right?
Oh, for printing everything out, yeah, or
Yeah.
whatever it is. Yeah, that's it's if you're not getting your head around trees, leave it alone.
Hmm. Yeah, I haven't really touched that yet because I don't think I've really finished the main stuff completely yet.
Make sure you finish the main stuff completely.
Yeah, I'm almost there. Like I'm just asking because I was a little confused by some of the wording for it. Like,
It's using
it's
recursion,
yeah.
which means the function calls itself.
Mm-hmm.
So the definition of recursion is C recursion. That's the running joke. I love it as a joke. I mean, it's a dad joke, but it's a good solid dad joke in that respect. It is recursion is it calls itself for the definition of recursion, C recursion, because it loops around by just calling itself. In this case, it's this node then calls the same function in the next node in the tree, which then calls the same function in the next node of the tree. It is, and by doing that, I don't have to worry about what the tree looks like. I just say, just the stuff below me, do your thing, and it does its thing.
Right.
It's hard to get your head around. I
Mm-hmm.
we'll crush hopes and dreams in most computer science classes with just that concept. So I'm not expecting everyone to get it, but some people might get it, and great if they do.
Yeah, unfortunately, I haven't really had time to look at it yet.
Yeah, if you have other things to do the other things.
Mm-hmm. Yeah, it's just for the three other functions the isChild is connected in that. I just noticed in the instructions it says they only take in one node. And so that's why I was kind of thinking that it's
Because you're in a
called by
node.
a node.
You're
Mm-hmm.
in the node. If I'm in node A and I say, are you connected to, like, if I want to see my connections on LinkedIn, I go into my account and say, who am I connected to? I don't need to say me. I'm already there. It's my account. I'm just saying who my connections are. So am I connected to Tony Tang? I don't have to say me as is connected Tony Tang? And it says yes. Why? Because I have a connection to Tony Tang.
Right.
I don't know why
Yeah, I
I'm
guess
bringing
my
up
question was just like to have it set up that way. The functions would need to be defined in the tree node CPP so that a node could call that and say, am I connected to something else?
Yep, that's it. The tree
Okay.
node knows about it, not the tree.
Yeah, because right now I set it up in main, the function, so it's got to call the two nodes. And so I realized after rereading that, I think I did that wrong.
Yeah, you're thinking like C coding, and you got to.
Mm-hmm.
I'm trying to get people into thinking about objects. The object, from the object's perspective, is connected. Makes sense. I am the object. Am I connected to this other object?
Okay, yeah. Yeah,
If
just
that
wanted to
makes sense.
clarify that.
Yeah,
Yep.
nice.
Thank you.
No problem. I think we're well past time. Sorry, everyone. I know I programs take. I did. What's 5207, by the way? Yeah, it. You teach it. 5207. Is that the data of interactive? Am I 5207? Don't know what I teach anymore. Data interaction. If that's data interaction. Oh, okay. Yeah, maybe it is one of my things. Okay. Okay. I don't know what I teach anymore. I go along for they tell me teach this and I go, okay. Yeah, 5207 is the data interaction. It's the grad course for visualization. The equivalent is 2100. iTech 2100 is the undergraduate version of it. I'm teaching this term. So if you know anyone that's taken the course, you can cry together about how much of a despot I am or something. So why are you seeing it in the videos though, considering my thing, they should be completely separate? I know it's not an undergrad course, 5,000 is always graduate. I wouldn't think you would be seeing my videos on that. I have a playlist for only 2,400. Because it's going to be a hard time finding the correct videos. Why would you see all of those? Yes, make sure you have a playlist rather than just looking at videos that I make, because if you just look at videos I make, it's going to be a lot of noise to little signal. There's also 2100 videos in there as well, and multiple terms of no problem, no problem at all. Yeah, grad course in data interaction, data cleaning, visualization of data, that sort of thing. That's actually what I do, not, that's my PhD area. All right, no problem. I can even give you logic lessons if you guys want logic as well. I used to teach that for a living, so good times. Uh, anyways, guys, it kept you really long, but it was for your question, so I don't feel that bad about it. But at the same time, I'm going to go grab some supper to make sure my kids have not stabbed themselves, and I will talk to you guys all later. All right, thanks everyone.